Good evening, everyone. I'll just start the class in a minute. I'll just wait for wait a minute or so. Good evening, everyone. Welcome to today's class. And we are here for the fifth week of problem solving session. And today's topic is prefabricated items. I am Purvita Shamonto, and this course is being coordinated by Professor Shumana Gupta, and we are from IIT Kharagpur. So, just a brief once again, the same introductory which we have each and every week. So this interactive session will run till week 8 every Tuesday, and we answer some of the questions which are related to the graded assignment, and this will also help us to understand, or rather this will help us not only in the graded assignment but also in the final examination which you all will be given. Apart from that, we also have the discussion forum where you can post your questions, and the answers and any kind of queries will be answered in the discussion forum itself. So let's come to our main topic where we'll see what we have already learned in this week 5. So the first thing that we saw that was taught in our lecture 21 was about introduction to prefabricated items. Then we learned about the concrete masonry unit, CMU, AAC, and pavement blocks, concrete pavement blocks. For the next lecture, lecture 23 was about precast wall panels. Lecture 24 was about floor panels, and lecture 25 was about column foundation and ferrocement. So these were the topics that were covered in week 5. And so today's session, from this 5 lectures, we will see some theoretical questions as well as some pictorial questions. So today we do not have any kind of numerical questions from this part. So let's move to our first question where we have that AAC blocks are cured in an autoclave under. So this under is basically, yeah. I would request you all to answer this question. So the options that we have includes heat and cold temperature, extreme heat without pressure, heat and pressure, and the other one is pressure. Yes, Harsha says C. I hope everyone agrees with Harsha. So yes, the answer is heat and pressure. So these are quite direct questions, easy to answer questions. But let's see what do we mean by autoclaving of aerated concrete blocks. So basically, what are these AAC blocks? So we have also learned we have learned that these AAC blocks are basically the precast foam concretes which are basically made in such a way that aeration happens within the blocks. And as a matter of fact, this after this aeration happens, this blocks are basically molded, and they are put into this autoclaves. Okay, so this autoclaves, what does this autoclaves do? So they helps to, they in fact, this particular machine, they are used to provide heat and adequate pressure, so that the this particular mold, it can be converted into this AAC blocks. So when this AAC, if we look into the different properties of AAC block, for example, we learned about the compressive strength of AAC blocks, which is something around, this 8 Newton per mm square. But apart from that, the dimensions. So the dimensions can vary, and also there are code specific codes which mention about the different types of requirements of this AAC blocks when this are manufactured. And the length can be 600 mm, this can be 400 mm as well. The height can be 200 mm, and the width can be 200 mm. So it depends upon what is the size of that particular AAC block. But yes, apart from that, if you remember that AAC blocks are generally not generally, they are not hollow blocks. Okay, so they are basically solid blocks. Okay, and this AAC blocks, this has got a number of advantages when we this particular AAC blocks, when we compare it in comparison to, just a second, yes, when we compare it with this the conventional brick, the clay bricks that we had learned. For example, the thermal performance of these AEC blocks are better. Also, when we do this, when we use this AEC blocks, minimum amount of mortar is required. Also, you can avoid the plaster war for when you are using this AEC blocks. So these are, apart from that, we have also learned that this transportation cost can be minimized in case this if possible, like this. So these are some of the advantages of AAC blocks. So I hope the entire concept of what this autoclave is clear to you all. So the next one is just a second, just give it a so next, second question is about identify the following type of precast item. So can anybody give a guess to what this image is all about? This particular, if I just say, these are the tendons, and this is the concrete, the block, and the tendons are pulled, so they are kept in compression. So yes, now any guesses from you all? No one? Okay. Just a second. Yeah. So this is basically pre-stressed concrete. Okay. So pre-stressed concrete, ma'am has touched upon this pre-stressed concrete. So I'll just tell you what this pre-stressing is all about, because if you remember when we were watching the videos of this floor slabs, there also it was written that pre-stressing of the slabs are being done in order to manufacture those huge spanned this floor slabs. So basically what this pre-stressing is all about. So by now, I think in last class we were also talking about why this reinforcement bars are given when we are in kind of in case of concrete construction. So what we said, what we did, that we did that concrete is good, like it can take the compressive load, however it is not capable of taking tensile load. So for that reason we have to put reinforcements, rebars, so that these reinforcements can take the tensile load, or it gives the tensile strength to the concrete block. So this was the entire concept of why these reinforcement bars are given. So that what we learned was the conventional style, where the reinforcements are bars are provided, the stirrups are there. So stirrups basically they hold the reinforcements in place, and then you place the concrete, and then the concrete is cured for 28 days. So that was the basic thing. But for pre-stressed concrete, what happens? So if you look into the, if you just think about I'll just try to show you with the, I don't know, okay, just look over here. So if you just consider this to be a, concrete beam. So if reinforcements are not there, what will happen? There will be deflection, right? So this kind of sagging will happen. So in order to avoid this, what happens? We provide tendons. Okay, so here what happens? These tendons are given. So when these tendons are given, So what will happen? So these tendons are basically what? Pre-stressed this steel bars, okay, or reinforcements. So when these things are given, what happens? The entire this deflection of the concrete block, it moves up like this, okay. But when there are load on it, okay, when it is exposed to load, this entire concrete block or this whatever concrete construction, what happens? Due to the presence of these tendons, pre-stressed tendons, what happens? The deflection doesn't happen, and the concrete, the casting, it remains straight due to the presence of this reinforcement bars, okay. Now this reinforcement bars, how are they placed, and how these pre-stressed concretes are made? So basically what happens? So basically what happens, so a particular pre-stressing bed is created at first, okay, and then if you see these tendons, they are pre-stressed, okay. If you look at the arrows, so the one side it's locked and from the other side it is pulled, okay. If you look into this particular image also, you can see that these tendons are basically pulled in this direction, okay. So they are pulled, and now what happens? Concrete is poured on it. Concrete is poured on this part, so you can see here, so concrete is being poured. And then what happens? Once the concrete it gets cured, this particular thing, this particular tendon pulled, tendon, or the this tendon is kept in compressive strength, in compression, or rather not compressive strength, but it's kept in compression. So once the concrete, it gets cured, these tendons are slowly released back, and then we get this particular block. So this is known as pre-stressed concrete. So here what happens, this tensile, this steel that is used, the rebars that is used, or the reinforcements that is used, they are high tensile steel, which has got this ultimate strength of something around 2100 Newton per mm square. So you already know the compressive strength of bricks and AC blocks and all these things, and if you compare the ultimate strength of this steel with it, so you can well understand the kind of difference, okay. So these tendons are used, and they are stretched up to their 70 to 80% of their ultimate strength. And then once the concrete is casted, then what happens? Those this tendons are released, and this type of pre-stressing this concretes, they can be used for building roofs, bridges, or floors which have longer unsupported spans. So these are this is how pre-stressed concrete is made. Another one is here you see, this is known as post-stressed concrete. So post-stressed concrete is basically a form of pre-stressing only, just there is a basic difference in the way it is manufactured. So what is that difference? So in case of pre-stressing, what did I say? I said that first the tendons are pulled, they are placed and they are pulled, and then the concrete is casted, and then once the concrete gets cured, then those tendons are released. But for a post-stressed concrete, what happens? First the concrete is casted with a duct. Okay, so you can see in the this particular cross section, there are ducts which are left, okay. So these ducts are made, and then what happened after the casting of concrete is done, then this this anchors, this or this tendons are tensioned, tendons are basically inserted, and then they are once again released. So this is how this post tensioning of concretes are done. So this is once again, if we talk about post stressed concrete, this is also a form of this pre stressing only. But here what happens, this steels are basically, in case of pre-stressed concrete, this steel is stressed before the concrete has to support the service load, whereas for post-tensioned concrete, what happens, that the concrete is poured and then the tension is applied, okay. But we understand that it is still stressed before the loads are applied. Okay, so that is why this is known as post-stressed concrete. I hope this part is clear with you all, the two types of tensioning of concrete. So any of the method can be used when it comes to pre-stressing, the concretes, or when we are building this long span unsupported slabs, and in that scenario, this one of the types can be used. Okay, mostly we see this pre-stressing part only. Okay, so now coming to our third question, which says that which of the following is not an advantage of prefabricated items, and the options that we have are lower cost of construction for large scale production, rapid construction that can be assembled on site, quality of items can be controlled, and easy fixation of plumbing and electrical services. So this is quite an easy question, I guess. So I would like Rashmi says that I asked which is not an advantage. Okay, just so you say that lower cost of construction for large scale production cannot be achieved for prefabricated items, Rashmi? Yes, any more answer from anybody else? Rashmi says yes, lower cost of construction for large scale production. Okay, I get another answer. Okay. So basically, which is not an advantage, is basically the easy fixation of plumbing and electrical services. So this cannot be done. Why? I'm coming to it. But before that, lower cost of construction for large scale production is an advantage. Okay. So what happens if there are large scale production? That means it's not for just one single small unit of one residential unit or something like that. If it's a huge mass housing projects, just take an example of this mass housing projects, and then you have to build similar kind of modules. Okay, so then what will happen if you go and tell the factory who are making this prefabricated items, if you tell that I need this 1,000 units of, not 1,000, maybe more, but yes, just an example, that I need 1,000 units of this particular prefabricated item. So obviously what happens, there will be economies of scale. That means for huge production, the cost will get reduced. So the lower cost of construction for large scale production is an advantage of the prefabricated when we are using prefabricated items. Okay, but mind you that large scale production is important, because you can't, because the factories or even the the developers who are making it, they won't get any kind of profit if it's a small scale project, and then you are using this prefabricated items. In that case, it will be a loss. Okay, then rapid construction that can be assembled on site, of course it's a rapid construction. Okay, so it can be easily assembled on site, however, provided the fact that skilled laborers or skilled person or skilled technicians, they are there, only then of course this can be assembled very rapidly, and the construction method is also very rapid. Okay, when we use this prefabricated items, because things are already cured. For conventional method, what happens, we need to keep it for curing, then plastering happens, and all these things you have to cast, you have to then keep it for some time, and then you come back and then you use it. So these things can be, this particular time period can be avoided when you are using prefabricated items, because already the materials, they are already in the ready-made form, you get it from the factory. So the only time that is being taken is in the factory. After coming to the site, you hardly, it takes hardly much time to assemble everything if there is skilled person. And of course the quality of items can be controlled, because it's a factory made thing, and appropriate proportion, because we also studied, if you all remember the batching thing. So when this appropriate mixing of items are being done, so these are all done in the factories. So the quality of items can also be controlled, and this entire production happens in a controlled environment. So these are some of the advantages. However, this fixation of plumbing and electrical services are not easy. This is one of the limitation of prefabricated items, because Why it's not easy? The reason being that you have to be very particular with the building design. Okay, that okay, so this will be, so from here to here my this electrical line will go, so from here to here, so accordingly you have to, you have to provide instructions, or accordingly you have to prepare drawings. So the only reason being that later on if you want to change it, you won't be able to do it, because ultimately it's a prefabricated items, things are already made beforehand, it's coming, you are just assembling it. So any kind of changes, the flexibility of changes is not there when it comes to prefabricated items, and that is why this easy fixation of plumbing and electrical services are difficult. So you have to plan it, you have to plan beforehand, and accordingly only after that you can start the entire process of this plumbing and this other things. So there are several other limitations when it comes to prefabricated items. We have seen that there are advantages, but at the same time some of the disadvantages includes that heavy members needs to be transported. So you need to be very precise when this transportation is happening. Skilled workmanship is required, and people need to be like the laborers, they need to be very appropriate, or they need to be very much cautious when they are transferring it from one place to another. Also the very heavy items are there, so sometimes it happens that it's very difficult to move it from one place to the other. So you can well understand from the like the materials that are being used itself, you can easily understand what are the difficulties you can face. Apart from that, very small margin of error is errors are allowed, because if there is a slight mistake, then one item will not attach with the other one. So this type of margin of errors needs to be avoided. Like, rather margin of errors are they are very less, so you have to be very perfect when it comes to prefabricated items. Also design flexibility is very less, because you just can't, as an architect or as an engineer, you just can't build anything and everything you wish to, because you have to understand that these are factory made things, this will come and this will be assembled, and you need to be very cautious with the kind of design. There should be some kind of simplicity also in the design that is being done. And apart from that, this entire repetition of form affects, because we as architects, maybe we envision something very different, and not the very monotonous looking repetitive building objects being used. Apart from that, heavy cranes are required when we are installing the different parts. So these are the some of the limitations which we had already studied in our video also. So now coming to our fourth question, that is, choose the correct match among the following precast concrete units with their images. And what do we have? Precast floor slab, we have paver blocks, or concrete pavement blocks, whichever way you want to understand. Then hollow block masonry and cleat. Yes, quick answer. What happened today? I find that the response rate has reduced a bit. Okay, Akash says A. Okay, okay. So I get some of the answers, and yes, I guess not guess, but yes, these are correct. Where precast, this is basically the precast floor slab. This is the cross section. If you, I'll show some of the images in the later slides. But yes, correct. And then this is the pavement blocks, and then we have what, hollow. Yeah, this is the hollow block masonry, or CMU. This is the hollow block, and then this is the cleat. Absolutely correct. So I'll just quickly go through, like, if you look at the images. So this is the hollow core, this concrete masonry, and these are mostly made up of composition is Portland cement, sand, clay, and shell or slate. And apart from that, some kind of admixtures are given. Why these are used? This is the concrete masonry units, and concrete masonry units can be of two types. It can be solid core and it can be hollow core. So the image that you see here is of hollow core. Okay. So basically, why do we prefer or why should we prefer to use this kind of concrete masonry units over the conventional bricks? Obviously because of high structural capacity. Apart from that, their resistance to fire, or their acoustical advantages, their thermal performance, the kind of thermal performance that it provides. So all these are some of the advantages. Apart from that, we also studied that when we were talking about AAC, that minimum amount of mortar, you can see that just in this this joineries here, maybe a little bit of this mortar is being used. Apart from that, you get a very smooth and a very nice finish from outside as well, which is very different to when we looked at the brick work, right? So that these are some of the reasons why we use the CMUs. And also, if you all just go back to the CMU lecture, so you'll find that there are different types of CMUs. Different types, like there are CMUs which can hold the sash units, that is the this window sashes. So the design is different. So it's something like this, and it can be hollow. So yes. And apart from that, there can be just stretcher CMUs also. So there can be different types of CMUs as per the requirements. Curve units are there. So curve units are basically it has got no grooves, it's just simply this, and then in between if it's a hollow one, so it can be a hollow one. So those are the curve units. Okay. Now coming to the concrete pavement blocks, so we all have seen how concrete pavement blocks are, and these are also precast units. And the the important thing about this pavement blocks are the interlocking function, or the interlocking capacity or ability, what however you want to explain. So it's the interlocking system of this concrete pavement blocks that makes it so much useful, or so much beneficial when it comes to using when it comes to the use, the way where we place it. Apart from that, if we look into the composition, it's made of crushed, semi-crushed aggregates, blast furnace slag, silica fumes, fly ash, and cement in different proportions, and then they are molded. Apart from that, the colors that we see, so pigments, so several other mixture, this chemicals are added to it, so that we get a pigmented concrete block. So I think you have seen this red, yellow, all these things. And then we also talked about precast floor slab. So precast floor slabs, once again, these are pre-stressed concrete slabs. Okay. And they can be either solid materials, or they can be longitudinal. They can have longitudinal hollow cores also. So in this image that you see, these are these are solid, this T flanged and webs. So we also studied that it can be double T also. So it can be something like this as well. Okay. And they can be of several, the depth can be different for different types of materials, and you can make them as per your requirement, as per the span is. So these are the this is the image of this precast floor slab. Okay. So next question, which I, and okay, another thing that I forgot to mention, that is the cleat. So this cleat is basically something that holds the wall panels. Okay. So the wall panels can be kept here, or yeah, they can be placed. And also this cleats, this can be single cleated, or it can be double cleated. So for double cleated, there will be two spaces, right? So there will be two like this. And so you can check once again, go and check the lecture. So these cleats are basically used to hold the this wall panels. Okay. So that, oh, now coming to our fifth question, which says that match the grade of concrete pavement block with its, oh sorry, match the grade of concrete pavement block with its corresponding application. So what do we have? We have M30, M35, M40 and M50. And where do we use this M30, M35, 40 and 50? So a quick answer from you all. So the different areas where we can use can be shopping complex and plaza, footpaths and city streets, railway station, bus terminal, and gardens and patio. So the one hint that I can give you all, or maybe you all know also, is that so higher the this grade of pavement block, this higher graded pavement blocks are basically used for places that are having higher traffic. So higher grade, higher traffic. Right. Okay. So I got two answers. One is A and B. A and B. Okay. They are quite poles apart. But yes, I. Any more answer from anybody else? So P one. Okay. So if M30 is for places with no traffic like Patio and Garden. Okay. So now I'm getting another. Okay, let me see what's the answer is. Yeah, it's obviously B. Akash, yeah, Harsha has corrected her answer. Absolutely correct, Harsha. So basically, this M30, as I said, that higher the grid, higher the traffic. So obviously, if there are no traffic, like gardens and patios. So there we can use M30. So M35 we can use for shopping complex and plaza where we have light traffic. M40 can be for this footpaths and city streets where they are medium traffic, and M50 are for this type of pavements can be used for places with high traffic or heavy traffic. Okay, so for example, railway station, bus station, and also heavy buses. Also the footfall in railway station is very high. For bus terminal, also the footfall is very high. So for that reason, there we need to use this higher graded pavements. Okay, very good. Apart from that, we can also see how this this pavement blocks are placed. So if you look that there's this one particular age block is given, age restraint, so that basically keeps the paver blocks in place, because you can understand that these paver blocks are basically interlocked with each other. So what will happen if one comes out, then all the other will start coming out. So for that reason, there should be at least at first when we are constructing it, there should be some kind of edge restraint, so that will keep the things in place. Obviously if there are if there are any kind of damages in with a due with due time, then some places some of the concrete blocks needs to be replaced. So at that point of time it may happen that one of the block from the middle comes out, so that's a different thing. But when we are constructing it, we should be placing it such a manner that it doesn't comes out easily. So for that reason, this age restraint are given, and the base platform is basically prepared with the help of this sand or gravels. Smaller diameter size gravels are used, and then this different. It depends upon what how many layers of this base course will be given, and then after that the sand, or as I said that the sand or very minute small sized gravels are placed, and then on top of it this particular concrete paving blocks are placed, and then the space in between the concrete blocks, they are filled with the help of sand. So this is how the entire pavers are basically placed. And as we also learned in our video lecture also, that this kind of pavers also these are advantageous in the way that it helps in groundwater recharge as well, because water can easily seep to the groundwater, because it's not filled with concrete, or it's not filled with asphalt or any other kind of materials which is impervious in nature. So these are basically placed in such a manner that pervious materials are used for filling the gaps in between. So these are some of the advantages of using pavement blocks. Okay, now coming to our next question, which says that hollow core slab is represented by. So these hollow core slabs are basically a part of load slab. Okay, I'll show you the image. You all have seen the image of solid core slab with T flanges, web and flanges, T cross section. So now I'll show you the hollow core slab also. Yes. Any answer from anybody? Do I see? No, no one. Okay. So it is 4HC6. So what's this 4HC6? So for hollow core, this 4HC6 is basically 4 feet is the width and 6 inches is the thickness. So that is how we represent, and HC is of course hollow core, and this length can vary from 40 feet to something different also. And apart from that, thickness can also vary from 4 inches to 8 inches. So when we say HC6, so it's basically the thickness is 6 inches. So if you look here, uh, there are this hollow. So this is what hollow core is all about. The concrete is casted in such a manner. So basically ducts are inserted before placing the concrete, and that basically leads to the formation of this kind of this hollow cores, and later on this ducts can be taken out. So that ultimately gives this particular form. So these are hollow core slabs, and these are extensively used. Uh, and one of the reason why these are used is basically to reduce the overall weight of the concrete, or of the material, or to reduce the use of the concrete. But this doesn't mean that the strength of the concrete decreases. Okay, the strength remains the same, the type of reinforcements that are used, they also remain the same. However, at the same time, there some portion of it you can eliminate the use of this concrete so as to make it lightweight as well. So you can understand the kind of span it covers. So if you can reduce the weight, it will ultimately reduce the entire load that is being transferred to the foundation. So that is why this kind of hollow core slabs are often used for in case we are using this prefabricated materials. Okay, now the next question: identify the construction system of wall panels. So, can anybody um take a guess? We have already learned in our video lectures, but yes, if you all can remember. So, this is a kind of wall panel. So, taking a clue from the type of wall panels that we had, chicken mesh, yes, chicken mesh. I guess we'll study about chicken mesh later, but this construction type, chicken mesh, maybe it's a part, but here chicken mesh is not used, or absolutely like it's not exactly the right thing. Anybody else apart from Rashmi? What about Harsha? Okay, I'll give the answer, don't worry. So it's expanded polystyrene core panel system, or the EPS system. So in EPS core panel system, what did we learn? We learned that there are this welded reinforcing mesh that you can see over in this particular image. This 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 kind of thing. So yes, so these are basically the welded fabric, and then what happens in between these two fabrics, there is a layer which is expanded polystyrene sheet. So this expanded polystyrene sheet is something which has a very similar composition to that of what we commonly call it as thermocol. Look, I think thermocol you all have heard about it, and we all have used it. So this thing is basically placed or sandwiched in between this two welded wire fabric, and then what happens, then on top of that, I mean on both sides of this particular wire, not mesh exactly, but yes, yeah, mesh only. This is reinforcing mesh only. So on both the sides of this reinforcing mesh, what happens, shotcrete is applied. Now what is this shotcrete? So shotcrete is basically concrete or mortar which is sprayed, okay, on top of this welded wire mesh, and with the help of a hose, there's this particular hose, and at a very high speed or at a very high velocity, the concrete is just placed on it. So that is what shotcrete is all about. So the shotcrete basically covers up this entire welded five wire mesh, and then in between we put this EPS, or the this EPS is basically urethane expanded polystyrene. And using this, what happens, if you see here in this particular image, the shotcrete is yet to be you know given. So this is somewhat the basic construction of EPS system. And also this these dimensions are generally 1200 meter wide, which is 1200 meter means 4 feet, and in length it is 300 mm. So 10 feet. So 10 feet by 4 feet dimension, and overall thickness ranges between 80 to 30 mm. So you can go through about this in details from the BMTPC website. So these particular BMTPC, they are particularly using this kind of material. It is being used for mass housing projects, and this is a new kind of material that is being widely used. Okay, now the next type of thing is that is PUF core panel, or continuous sandwich PUF panels. So what is this? So for PUF basically stands for polyurethane foam. So this polyurethane foam, what happens? This particular polyurethane foam is sandwiched between two galvanized, this GI metal sheets. So this GI metal sheets are there, and then in between there's this polyurethane foam. And then this particular foam basically acts as an insulation core, and it provides this particular material, this sandwiched panels, these are also being used. And these panels can be used for the construction of both wall and roof. And as you can see, this PUF, this particular material, this has got a texture something very similar to, you can see the images, the real images, it's very similar to that of sponge. So it has got something like that, but it's not exactly, but since it's a foam, so you'll get that feeling. But yes, the composition is with polyurethane, and it's sandwiched, and it also gives better structural stability as well. Not only does it provides you with it has this insulation core, but apart from that it also gives structural stability, so that you can use it for use it in areas which has got wider spans. So you can easy, so these are another type of material that is being used. And also you can get details about this in BMTPC, and the file is attached. You can always go back and check it over there, how the construction can be done, what all is required. You can find the details over there. Okay, so now coming to our eighth question. So in eighth question, what do we have? Identify the wall construction system. Yes, any guesses? Does it looks like any kind of
Uh, Definitely, pattern
huh? Once more, Azizu.
the design and the pattern is the apply the features of Fibonacci square. Uh, the construction,
Azizur, your voice is breaking. Can you please use the chat box?
I would say
Huh.
the construction pattern is designed. Uh, the construction is the pattern is Fibonacci pattern. Uh, Fibonacci square pattern, which was applied for building. I mean the pattern of
Are
definition
you
of the
saying
pattern.
the word waffle? Because your voice got louder, but it's not very much clear. I don't know why. You can always use the chat box, Azizur. I'm really sorry because I can't really understand the things that you're telling. Maybe because of network connectivity. Okay.
No problem.
Okay, okay, okay. You can use the chat box, so it would be good because you told a lot of things, but I really couldn't make what you are saying. So just use the chat box, okay? No
Yeah,
issue. Okay, so I get some of the answers at wafflecrete. Yes, exactly. It's the wafflecrete wall panel system, and this wafflecrete wall panel system. This, these are basically, if you look into the image, so these are this ribs. Okay, so both longitudinal and latitudinal ribs are used, and with the help of this rib panels of reinforced precast concrete, this entire wafflecrete panels are built or manufactured. Okay, and this what do they, like the core elements of this wafflecrete, basically what do they have? It has lightweight insulated precast insulated molds, insulating curing covers that can be used in conjunction with waffle crit molds. Then we have some specialized equipments which are desired. So basically, it's the waffle crit mold which is, which is a important thing. And then considering the mold, then we put different types of, not different types. Then we put the concrete, which basically ultimately gives a kind of, this. This waffle like structure. So it's basically once again very lightweight, because we are constructing, the construction methodology is such that it helps in reduction of use of concrete. So this type of waffle crete construction, these are once again used when there are long span, and you can easily you can use this waffle crete system. So here also in this image also you can see how this entire, this building, with this is just a part of the building, but you can see how this entire building, apart from that, you can also find it, this waffle crete system, not only wall panel system, but also, they are used, waffle constructions are used for roof also. So there also you can find this kind of this waffle or coffered roof. We generally call it as coffered roof. So there also we find. However, the basic principles remains very similar. Okay. Next, we have another question. Which of the following is true for a waffle slab? So, longer slabs with no ribs and lightweight, or shorter slabs with no ribs and heavyweight, longer slabs with ribs and lightweight, or longer slabs with ribs and heavyweight. This answer we have already, like when we were discussing, like just now only, we have already answered. It's just a repetition, I feel. Yes, Akash says C. Any more? Anyone with any other answer? Okay. So yes, basically, yeah, Rashmi, absolutely correct. So it's basically longer slabs. So we can, cover up a longer span, and also we can. I mean, the most important thing is that it's also lightweight because of the type of construction that it is. If you look into this particular cross section, so you can see this waffle slab voids are there, and apart from that, there are this reinforcements. So these reinforcements are already there, ribs bottoms, and whenever this, this without any hindrance, without any columns, any kind of, vertical members, you want to cover up a long span, there you can use this waffle slabs. And these waffle slabs are used for both floor slab as well as ceiling slabs, as I just said. And also when we want to cover up, suppose you're trying to cover up this particular, span with a very conventional kind of concrete slab, the kind of thickness that the kind of thickness that the concrete slab is having is much, higher in case of this conventional slabs. However, the waffle slabs, for waffle slabs you can easily reduce the overall thickness of the slab, so that way you reduce the overall usage of the concrete, and also you produce a much more lightweight uh, system. So that is what waffle slabs are all about. Okay. Now coming to our 10th question. So what does this 10th question says? That we have to match the joining methods with the place of application, where we have backer rod and sealant, brazing, dowel, and bearing pads. And on the other side, we what do we have? We have connector using successive panels. We have fixing of concrete masonry unit. We have precast columns. We have joining of metals and welding plates. So these are the options we have. So any answer from you all? Harsha says C. Okay, I'll mark it. Any more answer from anybody else? Okay, I'm getting. Oh, I got a different answer from Sogant, and that is B. So why do I see? It's because, okay. So both of you understood that backer rod is used for welding plates. Okay. Okay, I got another answer, that is D. I think except the correct answer, I've got all the other answers. Okay, no issues. The answer, right answer is option A. Why option A? I'll just quickly explain. So P is backer rod and sealant. So it's used in fixing of concrete masonry units. Next is brazing. So brazing is Q4. So it's for joining of metals. Then R is dowel. Dowel is used for connecting. What's this? Connecting connector of fixing the successive panels, and bearing pads, which is what is it, precast columns. Okay, so this was the answer. I'll just quickly explain. I hope things will be clearer once you understand what this backer rod is and the other things also. So this is what backer rod image. So what is backer rod? If it's also given in our video lecture also. So it's basically a foam material, resilient foam material, which is polyurethane of circular cross section, which is installed under compression. So if you go and just check, randomly check the image of this backer rod, you'll see that it's something like that. I mean, looks like this. I mean, it's a long one. I just, so it's, this is, this is a foam material, and it's circular, and it's something like, it looks like this. Okay, and it's installed under compression. So where is it installed? So if you look into this particular image, okay, so these two are basically the same thing. If you just look into this particular image, so you can see this backer rod and caulk is provided over here. Okay, so this is the area. So what happens, this backer rod is installed under compression, okay, in a joint. So this is a joint between this consecutive CMUs, or this concrete masonry units, in order to control, it's provided, and also a sealant is provided. So sealant basically helps to keep the this particular backer rod in place in that particular joint, or in that particular joinery, and it basically provides a kind of support. That is what this backer rod is all about. So it's like it's providing a backing, okay, which is kept, this particular item is kept under compression. So this is what backer rod is used when it comes to. So it's basically backer rods are not only used for this concrete masonry units. You will also find that this backer rods are used when we are installing a glazing unit. Suppose this is a glazing unit, and you have to place a particular glass like this. So these backer rods are placed over here. So these are circular cross sections. So just imagine the cross section. So this is the glazing, okay, and this is the glass, and this backer rods are produced, and then they are sealed. So this sealant is also produced. So there also you can see the use of backer rod. So backer rod is not just used in this concrete masonry units for in the joineries, but also in several other kind of applications also. You will see where the basic objective is to provide a kind of backing with the help of this backer rod and the sealant. Okay, then this is what brazing is all about, to connect the two different metals. I think you all have already like you all have seen this thing where this gas and oxygen is provided, and these two metals are basically, the joints are uh, you know two metal joints are just attached. Then this dowel. So dowel thing is something which is used as a connector, which helps in fixing two successive panels. Now here I have shown you with an image of a wooden dowel, but also in case of wall panels also this dowels are used. So dowels can be basically, it can be used in different places. Once again, it has got multiple uses, but yes, the dowels are something very, very similar to this, where the narrower side is just placed, or it can be something like this also, and then one end is put through one panel, and then the other end is attached. Basically, when we are attaching two panels, successive panels, we insert this dowel. Okay, so that is what a dowel is. And the and if you remember, the other one was bearing pads. So bearing pads are used in precast columns. So what is that? So this is what bearing pad is all about. If you look into this particular thing, also you'll find the cross section of bearing pad in our lecture material also. So these beams are set on this bearing pads of columns, and this bearing pads, they act as buffers. Okay, so they act as buffers between this is one separate concrete member, and again this is another separate concrete member. So these bearing pads are very important because they act as buffers between these separate concrete members, and they prevent it from any kind of damage. And also this bearing pads, they are manufactured from alternating layers of neoprene or natural rubber and steel sheets, and then what happens, they are molded under heat and pressure into one unit, and then they are basically fixed. When this vulcanization process is done, they are basically fixed into the particular steel materials, or the steel that are already there in the concrete, and then on top of it the other concrete panels are placed. So this is how this bearing pads are important when it comes to this precast columns. Okay, I hope this thing is clear to you all. Okay, now coming to our next question. So next question is, which of the following are advantages of a ferrocement? So it is economical and lightweight. It can be made to any shape and size. It requires minimum skill, and it cracks because of the chicken wire mesh. So Rashmi was talking about chicken wire mesh. Yeah, I think now she has got the chicken wire mesh. Okay, so Rashmi says P, Q, and R. This one, this one. This Okay, let me see the answer. Yes, absolutely correct. Harsha said B. No, 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 Harsha. It doesn't cracks because of the chicken wire mesh. Okay, so that is what ferrocement. I'll quickly explain what's ferrocement once again. And of course, you can always go back to the lecture material and check it. But yes, Akash, absolutely correct. It's A. So basically, ferrous cement are, this chicken wire mesh, this thing, which are of something around zero point 0.4 mm dia, this wire, uh, thin wires are used, and they act as this reinforcements basically. And on top of it, what happens, these they act as, instead of using this reinforced bars, this particular chicken wire mesh is used, and then on top of it, what happens, this concrete is, or not concrete, rather mortar is placed here. What happens, mortar means basically cement and sand. Mixture of cement and sand is placed on top of it, and no coarse aggregates are used. So that is what ferro cement construction is all about. This is also a prefabricated material, and this usage of ferro cement was done first in the year 1941 by the famous, very famous structural engineer and architect Louis Navy. So this is the image of Palazzetto dello Sport. So this is one of the first construction using this ferro cement, this dome that you can see. So this dome is basically made up of this ferro cement, and this is a prefabricated items. And Louis Navy understood that in order to uh, build long span structures which are structurally stable as well, and also you can give different kinds of forms, this ferrocement can be of very useful thing. So for that reason he used this particular kind of thing. And of course ferrocement is something which is very useful when it comes to this kind of construction. And apart from that, from India also we have seen in the video lecture that Ahmedabadni Gumfa. So that is also one of the very prominent example where ferro cement has been used, and how the domes has been, there are different domes, you can look into the images as well. So how the domes have been created with the help of this ferro cement technique. Okay. Okay, so let's see some of the buildings which are made of prefabricated items. I hope the last question was clear to you all. Okay, so this is basically Nakagin Capsule Tower. Okay, Akash. So this is Nakagin Capsule Tower in Tokyo, and so you can see how this is the basically this is the building, and you can see how this, these are modular units, and these are prefabricated, and these were placed to build this particular tower. However, in recently in April 2022 only, due to the difficulty in maintaining this particular building, the modules are they require continuous maintenance, and the kind of maintenance that is required for this particular construction is becoming tough. For that reason the government, or they have like in Japan, they have decided to bring down, or rather demolish, this Nakagin capsule tower. So this is a very recent news, you can say, where in spite of this is a very famous building by Kisho Kurokawa, and this particular this is an example of that modular construction. And however this will get demolished with due course of time. And another one that is which I already had shown you when I was talking about concrete building. So this is basically Habitat 67 Montreal, and this is one of the example, again a very beautiful example, where this precast concrete has been, or prefabricated items have been used, and then they have been placed, and this particular mass housing has been constructed. So this is another example. Also, if you all want to check the examples where precast concrete has been used, Sydney Opera House is one of the. I haven't given the image of Sydney Opera House, but yes, you all are aware about Sydney Opera House. So Sydney Opera House is a very good example where the this kind of the pattern, uh, this shells rather, they are this precast concrete units. So you can always, there are several other examples as well, you can see where precast concretes, prefabricated items are used, modular units are used. Also when it comes to modular construction, there are also several other things which you all can check upon. For example, the structural grid of modular construction. There are different types of grids. It can be rectangular grid, it can be square grid, it can be tartan grid. Okay. So when it comes to modular construction, what happens generally, you follow a particular grid. So here you have to place your first unit, then this unit, this unit, this unit. So this is one grid. So then this can be another grid, right? Then this can be another grid. I'll show you. So this is basically what tartan grid is all about. Okay. So there can be various other grids. So you can always explore all those things, and this precast and prefabricated items, this entire construction system. It's a very new domain, and you can always explore. And it's a very beautiful things where we are moving ahead of the conventional materials that we generally see, the conventional construction techniques that we generally see. So that is why this particular lecture is very unique and very special. And just go through the other lecture, the lecture material. And also if you all have got any doubt, just put it on the discussion forum, And that's all for today. So thank you everyone. And if you all have any doubt, we can spare a few minutes. Okay, thank you Harsha, thank you Rashmi, thank you all for joining once again. Thank you Marvin, thank you Azizur. Azizur, I couldn't understand. So if you don't mind, you can also write it down in the chat box. Thanks Azizur. You too have a great day. Okay, let's wrap up and let's call it a day. Thank you everyone. We'll see you again in the next class.